It's nice to see everyone's faces, all 200 of you. My name is Annie, and I'm a data scientist at Analytics Engines. I'm so happy to be here to talk to you about building context-aware systems that solve real-world problems. So we're going to be exploring context engineering for real-world AI. I've heard the word context flying about in the room since I came in, so I think it would be good to kind of expatiate on that. I thought to start us off with a question, rhetorical. Could you fix the issue the same way as the last time? And I want you to really think about how this question makes you feel. You're probably confused because I gave you no context. Every day we give LLMs vague and generic inputs, and we expect accurate and useful results, but that's just not possible because even humans struggle without context. So this talk is going to be about context engineering for operational systems, not chatbots, because I think we've had enough of those. So we're going to be exploring predefined workflows where you design what the model receives and how to control granularity and constraints for deterministic work in publishing, and in publishing specifically, because I want to prove to you guys that deterministic work is possible with LLMs. You're probably wondering why publishing. So we've been working, Analytics Engines have been working with a client called Danger. They're a publishing solutions provider since 2024, and we've been exploring how AI can complement, not replace, human expertise in book production. So on average, it takes about 12 to 24 months for a single book to go from manuscript before it even gets published. And a lot of this work, as you can imagine, takes a lot of deep understanding of documents, and a lot of time goes into actually understanding what the documents mean. So context engineering kind of comes into the forefront because it lets us build AI systems that understand the book structure and not just the text. So this is kind of a visualization of everything that a book has to go through before it even gets to publication. And I will be exploring two use cases, indexing and alt text. So you need to go through peer review, copy editing, typesetting, proofreading, all the boring stuff. But before I get into the case studies, I thought it would be good to start with the evolution of context in AI. And I think the beginning would be 2020 with the release of GPT-3 and earlier models. So these models had a fixed knowledge boundary, and they only knew what was in their training data. Fast forward to 2022 with the release of ChatGPT in November. What became more popularized was getting or writing instructions in a clever way to get the LLMs to do what we want. I think for a brief period of time, there was an actual job called prompt engineer, but thankfully that has reduced because I don't think that's an actual job, but that's my opinion. But then we move on to 2023 with the popularization of retrieval augmented generation systems. And these systems were able to access external documents at inference time, so this could arguably be said to be the foundation of context engineering. And around June last year, Andrej Karpathy, former OpenAI, and Tobias Lütke, CEO of Shopify, kind of popularized the term. And there's this really good paper by Anthropic that kind of explores context engineering for AI agents specifically. But I'm not talking about AI agents today because I think we've had enough of those today as well. So what is context engineering? So context engineering involves designing and creating what information the model can see and when. So this information could include the documents, domain knowledge, memory, tools that it has access to, the constraints, and the instructions. So it is the natural progression from prompt engineering. It's designing how to ask the model to get accurate results. So in prompt engineering, we would be thinking, if I was a prompt engineer, thankfully I am not, I would be thinking, maybe if I phrase the instruction this way, the LLM would do what I want. And the context window is very limited. So you have the system prompt and the user message alone. In contrast, If you look at context engineering, we're designing the entire information ecosystem. So the context window is richer, way, way richer. So you have the system and user message, but also we have the documents, the examples, constraints, instructions, so many things that could go into the limited context window because we want to make sure that we make use of the context window as much as possible and give it the right information that it needs to achieve the task that it was supposed to do. So why does any of this even matter? Context engineering closes the gap of what the model needs to know, how the information needs to be structured, and when the information should be introduced in the system. So we have the same prompts, same model, but vastly different results because of the context. So if I was building a system where every time a document comes in, we want the system to summarize the documents. If I was using just prompt alone with no context, we would just ask the system to summarize the documents. And here the model kind of has to do a lot of guesswork. So it guesses the audience, it guesses what format it should return in, it guesses the length of the summarization, and it guesses the focus. So this leads to more generic and often wrong outputs. If you have the context added, you would have the instructions, the role, the document metadata, the audience is giving the results to, the output format, and the constraint as well. So here the model is way more intelligent because it knows what it's doing, who it's doing for, and in what format to return it in. So the output here is accurate and actually useful. There are 6 essential components of context engineering. One is the role. So who is the system acting as? Here is where role prompting really comes into the forefront. So what do we want the system to act as? And then we move on to the task. What do we want the system to accomplish? Before we even talk about the inputs and outputs. So what information does the model receive, what data comes in? And here I think we could think about few-shot prompting, the domain knowledge it has access to, the documents it has access to, and the outputs. So what format should it even return in? So do we want it to return in free text? Do we want it to return in JSON? Interesting things, very interesting things like that. And we also need to specify what constraints, so what the system should not do at all costs, before we even think about the capabilities, which are the tools that a lot of systems are being built with. So the tools, the reminders, the references to keep the system in check. Now to the interesting part, the case studies. I'll be exploring AI-powered alt-text generation and AI-powered back-of-the-book indexing. So we built this, or the idea came from work with Data, but after that, we kind of built it into a full-fledged solution, which has become way bigger than I ever anticipated. But if you can imagine, if you're listening to an audiobook or you're reading an ebook, a lot of the ebooks that we read, they lack proper alt text for images in the books. And good alt text requires an understanding of why an image matters and not just the appearance. So imagine if you're reading a book about the history of the internet and you have a picture of a magnifying glass. You would not want the alt text to be a magnifying glass. You would want it to be a magnifying glass representing the search button, if that makes sense. So the way context engineering comes in is we feed these images with the surrounding text, the headings of the documents, and the captions alongside the image. So the model understands the purpose and not just the appearance. So you can think of the context here and the image here, and that makes a lot of difference. I have a very difficult image, which I think would really exemplify why our system really requires context. There's a lot of online alt text generators that exist now where you have to upload the images in isolation to get the alt text. So that's what I had to do for this one. But the difference is our system is able to process at scale. So you have documents in, documents out, with the alt text embedded into the document structure. But without context, we can see that these are comparative histology images with high and low inflammatory conditions, stained with whatever those are. But without context, I don't really gain a lot of knowledge. If I was listening to a histology book, I wouldn't really understand what the image represents. But with context, with our system, we're able to see that these are synovial tissue biopsy samples, and then we see the markers. We also see what the top row represents, and it shows that it represents the high inflammatory hepatotypes, and the bottom row represents the low inflammatory hepatotypes. And we also see what it corresponds to, and it highlights the differences in marker expressions between the two inflammatory levels. I feel like I've learned a lot just by hearing that. If I was listening to a book, I feel like I would gain more from the bottom row than the top row. That just shows you how context matters. And if you're listening to a math book or a physics book, imagine the difference that would make. To the next case study, which is something I'm still working on. It's been interesting, to say the least. But professional indexes, which are, if you're thinking about a non-fiction book or just an academic book, an index is basically a way to navigate the key concepts, the places, the people discussed within a book. So if you're reading a book about animals, what you would want to find in the index is different types of animals, dogs, cats, things about animals, essential things that you would think would be contained in the book. So professional indexes require expert judgment to determine what terms matter and how they relate. So if you would think about the hierarchical structure of a book index, you would have primary terms. So you would have a primary term like dog in a book about animals, and what you would have as the secondary terms would be specific species of dogs. But this is very expensive and time-consuming to do manually, and imagine how many non-fiction books I would have to read to be able to generate indexes, because the indexers have to actually read the book to be able to get the indexes. And how context engineering comes in is we give the model the chapter titles, the abstracts, the keywords, alongside the text. So it gains domain knowledge of the book, and it's able to output domain relevant and hierarchical entries. This is a brilliant example. So this is an excerpt of an index from a book about psychotherapy. So I built it first without context and then with context to really show our clients the importance of adding context to the window. So we have terms like Pope Innocent II. Why is this here? Not really sure. And then under that, we have Confession and Treatise on the Misery of Man. I have no idea how this relates to psychotherapy, but I guess I would need to read the book so I don't actually gain any knowledge from this index list. And then you have the book's main topic, which is psychotherapy, under pragmatism. That does not make any sense whatsoever. If I was a reader and I was trying to see what pages psychotherapy is being discussed in, my brain would not tell me to look under pragmatism. And that kind of shows you how readers have to think. And then we see perceived differential and within the sciences. Are these relevant? Probably not. And the relationship is not very clear. And then you look at the indexes with context added. So you now see the American Psychological Association, which is a relevant organization. We have Sigmund Freud, which is a name I'm sure everyone is familiar with. He's a key figure in psychotherapy. But most important, we have psychotherapy, which is the book's main topic, is now in a meaningful hierarchical entry. So we have the common factors, effectiveness, history, philosophical foundation of psychotherapy. And then we have Psychotherapy Action Network, which is another relevant organization. And this is just a snapshot of how important context is when building the systems. So we don't even need to build like a complicated system. We just need to give it a little bit from the document for it to be all the more intelligent. And we use the same approach, which is the context engineering approach, which is something we've dubbed, to show that document processing is really not that difficult if you know the libraries that you're working with. So we've worked with different book types like PDFs, which were a nightmare to deal with. We've worked with EPUBs, Word docs, XML documents, PowerPoint documents, and we're able to parse the document structure and extract the text before we even get into the context assembly. And this is when we feed the relevant title abstract alongside the text or the images. And then we go into real grounding, which is basically the role assignments, negative constraints, and the few short examples before we even get into the output generation, which are the relevant hierarchical entries for indexing and the contextually relevant descriptions for all text. There are lots of things I learned throughout these projects, but one is that context extraction is really not that difficult, and we're able to process documents at scale rather than uploading things in isolation, for example. But also that prompt design is very, very important. So the right information, the right point, and the right structure. So writing prompts in Markdown or XML formats really makes a difference, but maybe that's because these models are trained on Markdown or XML formats themselves. And the rule grounding and rule prompting really helps to keep the model on track. And few short example of what we expect the model to output in could not be overstated as important. So it's better to have more few short examples than a very long prompt, for instance. And the way we measure impact is by comparing the output with and without context, which is what I just showed you. And context is a way to ground the output in source material, which is a great way to deal with hallucinations. We also set temperature, which is something that I'm sure everyone is used to now. By setting the temperature to 0, the hallucinations decrease. And significantly, we constrain the formats by specifying what formats the model should return in. And we add validation layers and design prompts that make fabrication harder. I would like to leave a note that your system is only as intelligent as the context that you give it. Thank you.